Okay. Today we can talk about our progress in the research area, deep learning and machine learning. So, in this handout, we will talk about the progress and what are the things we have done, what are the things we have to do in the future, which means the upcoming years. So, uh, here. In my part was to detect fraud and eliminate the threats. So in my parts, so I will be doing policy-based fraud detection. So to solve the issue, I will be using deep learning. So in deep learning, so since I have used in deep learning, so you can be this is our dashboard. So you can see the link here in close neural network. So once you go into there, you can see all the available neural networks in the system. So actually, I will little describe more about what happened in the system. So when user whenever user want to develop a neural network for their product. So first you need to go into this server, and go to neural network, and he need to first build a new neural network model. So once he builds the neural network model, he can train his model with any of data set he has. So so that model can detect the fraud. After successful train, after successfully trained, server will publish the WSDL URL, which is a web service. So any other third-party application can consume the neural network service through that web service. So that is the main theory behind this module. So I will talk about now a little about neural network. So in here you can see there is 4 parameters in the search table, and neural network name, and full qualified class name, and inputs and number of outputs, and last train dataset. So here we given full freedom to user. So this is a highly customizable dashboard. So he can customize deeply. He can customize the neural model deeply. So as he can change the inputs and change the outputs, and he can add number of hidden layers he wants. So the reason behind we given the full freedom to user is because since we developing policy based neural network model, it will be different policies for one model. So one model has to be trained for different policies. That means users can add different data sets. So there we cannot have a constraint like okay, this number of inputs only can has data sets, and this number of outputs must be in the data set. So it will be a limitation, and it is unrealistic for practical scenario. So that's why we thought to give a full freedom to a user, so he can add a different inputs and different outputs for different data sets. So once he can go into a neural network model, so he can add a new neural network model by clicking this new model button, and it is redirected to configuration page. So in this configuration page, will be asking what is the neural network type. Okay, this is here we will support two neural network types. One is multi-layer neural network, and other one is recurrent network. So this dashboard server will support for real-time fraud analysis. So for real-time fraud analysis, we will be using recurrent networks. So as we know, in deep learning, to detect something, train data sets uh, real time, we most of the time we use recurrent network because it has that LSTM layer, learning short time memory. So that special feature can remember things, comes to it through a data pipeline. So if another pattern comes like that, it will remember soon that is got before. So that is the main advantage of recurrent network. So that's why we added recurrent network also. So for real-time training, detection and training, users can add recurrent network. So if user want multi-layer network, still he can add multi-layer neural network. So it's traditional neural network, since it is the traditional neural network and most of the people are familiar with it. So we added it also. Uh, in adding a recurrent network, so once you select a recurrent network, it will ask for model name. So you can give a whatever you want model name, and it will ask for a number of label classes. Label classes mean the number of outputs. So what are the outputs of data sets? So you can actually data set can have many number of outputs. So it is completely belongs to user. So he can add a number of outputs as he wants. So at this point, I will be at 4. So I will be uploading a dataset for 4 number of classes and a number of hidden layers. As I told before, he can customize number of hidden layers he want. So according to the complexity of dataset, he can add more number of hidden layers and more number of output layers. So for this point, I have added 21. So this is just for testing. So any number of layers you can add. So and after that you can add rename attribute. Actually this is for pre-processing part. So this deep learning model is built on top of deep learning 4J framework. So it will only support for datasets with numerical datasets. So you can't add datasets with string values. So you need to convert those datasets to numerical values before you pass this to neural network. Except the class attribute, you can convert other attributes to numerical values. Class attribute will be converted to numerical value by system itself. So you don't want to worry about class attribute. So it is handled by our system. So here you can add whatever you want. What are the data? What are the columns? This is the column name, and this is the column index, and this is the once again this is the column name and column index. So likewise you can add the column name and column index any number of column names and column indexes by putting commas. So once you added there, finally you can select a data set from here, collected. So for the moment, I will be adding data set with 49 with 42 attributes and 500 rows with this data set. So actually it has string values. So finally I will add the module. Finally I will add the module, and you can see the available modules now. So now I will show you the added data set. So in here, okay, that was simple technical details. Okay, so I will restart the system again. It is server failure, so I will restart it again and show a demonstration again. Okay, here I edit again. So, here I edit again. Okay, now you can see the newly added neural network modeling here. Test recurrent, which is I added now. So as you can see, the number of outputs is 4, and number of inputs, actually it is you can't the control it, because I will explain the reason for that. So first of all, let me show you the converted data set here. So okay, you can see the original data set from here. Okay, this is the data set I have uploaded. So as you can see, it is quite a heavy data set. It is from KDD dataset, intrude detection dataset, famous intrude detection dataset I have used in here. So as you can see, it has 42 attributes. That is massive attributes. That is very large number of attributes. So
Excuse me, Asanta.
okay,
I think the screen is stuck. Still, I can see the dashboard only.
okay, sure. Okay, can you see now?
Now, okay, now are you showing the data set only now? Ah,
Yeah,
okay,
yeah.
right, I got it.
Okay, this is the data set. I have originally uploaded data set. So it has 42 attributes, as I say. So it is quite a heavy data set. So you can't given this straight away to the model. So as you can see, there are string values in this data set. So those string values need to be converted to numericals. Otherwise, neural model cannot handle those string values. So I will be doing a data pre-processing part, and in there I will be doing data whitening part. In the data whitening part, I will be reducing these 42 variables to 10, 10 number of inputs. So I will be this is my theory. So any number of columns, any number of columns, I will be reduced to 10 number of columns. So in order to reduce the complexity of the data set. So you can see I will show you the converted data set in here. So okay, can Shakti, can you see the data set? Hello.
Yeah, I can see.
Okay. So here you can see the converted data set. This is the original data set, and you can see the converted data set. So as you can see, it is reduced. So it has only 10 columns. So last index will be for a label. So there you can see 0 1 0, those are the labels. So and these will be normalized values. So all the values will be normalized to between 0 and 1. And uh, actually for data whitening process in here, I will be using the Gaussian distribution. So using Gaussian distribution, I will be reduce this whole data sets to 10 number of columns. So this is the complete data pre-processing part I have done. So once this is successfully converted, you can uh, once it is added to the system, so you can now train the data set. So by clicking this plus sign, you can train the data set. So in here also you can add a data set, so you can change the data set anyway. So if you don't want to change, you want to train the added data set before. So you simply can click this train model, and it will start training the data set. So I will be not showing the train model demonstration, since it is a very heavy task, and it will go into 1.5 hour to train the data set. So it's not possible to show you the demonstration of train model. So actually, this is the summary of work I have done. So anyway, I got a accuracy of 8.8 0.85. That means 85% accuracy for a recurrent network, and I have got 96% accuracy with this pre-processing part. For pre-processing part, I have used special library called Veka, and it is a nice pre- nice machine learning library available in Java. So actually, you can use it in Python also. So it is mainly based on Java. So I will be using that Vika module to pre-process the data. So it is very accurate, and the okay now I have talked the works I have done, and now I will talk what are the works I have to be done uh, in near in coming up days. So these are the things I have to do in coming up days. So I have to I have to draw the ROC curve in the data set, ROC curve of the neural network module after train. So I will be working on that right now. So I will try to finish it with upcoming, upcoming 2 or 3 days. So and again I have to do the web service publishing part. That is the final part of my module. So once it was completed, my module will be completely finished and ready to shoot. So that is the uh, current status of my part. So actually, I will little show about the. Now I was demonstrate in the content. That's mean from the dashboard side. So now I will show some of the code and explain how I have done in that game. So this is how I have done it in that game. So this is the package structure of my project. So it contain all the controllers in here. So I will be not going to talk about deeply on MVC structure. It is not relevant to the research. So I will be talking about the research stuff only. So there you can see neural network package. It contain all the neural networks. So here we will be using this fraud detector deep belief and it means the recurrent network, and the fraud detector neural net means the multi-layer network. So in deep belief net, uh, so this is the model structure. It is based on, as I told before, it is based on deep learning 4J. So I have used deep learning 4J, and this is how I have done. I use the optimization algorithm as conjugate gradient descent, and regularization as L2. And for updata, I have used RMS prop with momentum rate. Actually, momentum rate is handled by this RMS prop. So and weight initializer as Xavier. So and they are as I told, the recurrent network has this special layer called LSTA, learning short-term memory. So it has I will be used. It has two type of LSTA. One is unidirectional and one is bidirectional. So I will be using that bidirectional LSTA, which means it will uh, queue a request and get the response from there. It is able to handle both request and response at same time. Um, and I will be using activation function as rectified linear activation function, which is best I think was because at the moment the sigmoid function is has only range between 0 and 1, and the tangent function has -1 and 1, and but when we talk about the rectified linear. It has lower bound to zero and upper bound is unlimited. So as the dataset progress, you can go deeper, go unlimitedly. So no, there will be no upper bound in rectified linear. So that's why I have chosen for chosen as rectified linear for activation function. So for activation in output layer, we will be using softmax function, softmax layer. So it will given the output as a probability. So these are the configurations of model, and in during the train model, I have used Apache Spark for training. Apache Spark has a special function called parameter average training master. So what is parameter average training master is it is the responsible part for training the neural network. So there you can add a number of batches, worker batches. So if you set worker refresh num batches to 2 means it will convert the data set into 2 mini batches, uh, and training and save updated true means from each batch to other batch, it will save the update and pass to the other from one batch to other batch. It will save the update and pass to the other batch, and the data will be repartitioned. Means repartition data means it will convert the data set into two parts for test. One is for testing and one is for training. So averaging frequency, that means the average size, and batch size means the number of batches will be in the data set. So repartition strategy means how we going to repartition the data set. That balance means it will convert data set into two balanced parts. One is train, one is for a test. So and epochs, number of epochs I have used 50, and that is the training part, and those two are the main parts of the neural network module. So now I will little bit go into the pre-processing part. So in this pre-processing package, I have the normalized dataset class. It will responsible of all pre-processing in the all of the pre-processing in the dataset. So in this pre-processing, so as you can see, it will first update the string values. So this is the first method will get triggered once this normalized dataset is called. So what it will do is it will convert those string values in the datasets into the numerical values, and it will store it into temp CSV data file, and then it will redirected to whitening data process in this whitening data method. So in this whitening data, it will convert this complete data set into reduce this complete data set into 10 number of uh, attributes. So once it will converted this to 10 number of attributes, it will store it in template CSV file. So after that, it will finally redirected to normalize dataset function. So which is responsible of normalizing the dataset, which means it will convert all the values in the dataset in between to 1 and 0. So after it convert the dataset, it will store it called normalize uh, an original file name, append the normalize keyword to original file name. So it will store as this name, and finally it will delete all these temp files, and it only contains the normalized dataset function and the original dataset functions only, files only. So that is the part, that is the normalization part happens in this dashboard. So that is, with that I would like to conclude the my explanation part. So I will give I would like to invite to Shakti to describe his part in his research. Shakti.
Okay, Santa, I think Santa has explained in deeply about whitening and other preprocessing stuff. So my part will be the predicting the most suitable protocol to use in the user store manager. So user store manager contains three types of protocol authentication protocols called SML 2.0 to 2.0, OpenID and OpenID Connect. So according to the requirements, user is need to select the what is the most appropriate protocol for their organization. So so my part will be to predict the what is the most suitable protocol. So then it will be helpful to decide and conclude what will be the most suitable protocol. So I'm using the protocol and I'm using the random forest algorithm for this prediction because this is regarding classification. So the random forest model is providing many features for the uh, classification and regression as well. So this part is mostly going with the classification. So the random forest model is uh, algorithm with contains a bunch of uh, decision trees, and also now I have uh, implemented in I use Spark libraries for the prediction, and the this will be the code. I haven't connected to the dashboard yet. So uh, this thing, the implementation will be like this. And also I needed to do some pre-processing part for the data set, because not only if we use just only the data set, it will be not increasing the accuracy. So there are a few steps. I think Asanta has explained most of them. So I have to clean the dataset by cleaning null values and other stuff. So and then I have to uh, do whitening process. I think Asanta has explained in detail whitening process, and also to increase the accuracy of the prediction. Uh, the ROC value is will be doing a much more important thing uh, to increase the accuracy. So I think so. I'm hoping to um, get a chart in dashboard with the ROC value, because for a person who is searching the accuracy of the algorithm and or the model, the ROC value gets a more uh, clear idea about the accuracy. So still I'm implementing process. I mean implementing process. So that pre-processing part is the thing that I have to complete. Then after I can connect to the dashboard to see that. That's it, Asanta.
Okay. So with that, we have concluded our route session for now. So we will be back with the new updates. Hopefully, we can finish with finish this week, finish this soon, and update with the finalized project. So we are hoping to release this as soon as possible. So within this month, we will try our best to release this within this month. So until then, bye bye.